So today we're going to work on Proofs Part 2, Reasoning and Algebra. This is the same learning target that we had in Part 1 when we were connecting reasoning in algebra and geometry. I know that this is something that you guys haven't seen. We started proofs the other day, and now we're going to continue and do an extension of that activity. We have a couple other postulates and so forth that we need to talk about before we get started with the proofs. One of them is the segment addition postulate. The segment addition postulate simply says that when we add this chunk of a segment to this chunk of the segment, we get the whole thing. So we added 5 plus 2 to get 7. The next postulate we're looking at is the definition of a midpoint. Definition of the midpoint tells us that if this is the midpoint, it cuts the segment in half. Cuts this segment right in half. We have this congruent segment and this congruent segment. The definition of an angle segment bisector, excuse me. That is this particular segment is the bisector. That means that it cuts AB right in half into two congruent segments. Now we have some other properties about angles that we need to know. The angle addition postulate, which says, again, kind of like the segment addition postulate, we add this angle and this angle to get the whole thing. So that means we add the 10 and the 40 to get 50 degrees. The definition of an angle bisector, just like the segment bisector, this particular segment ray right here cuts this angle into two congruent parts. This is 30 and this is 30. So now we're moving into the two-column proofs. The other day you did just proofs and reasons that things were happening. Now we're going to stack a bunch of equations on top of each other and start our two-column proofs. So in the directions, it says justify each step used to solve 5x minus 12 equals 32 plus x for x. And one of the things that you're going to learn in proofs is that they always give you something and then they ask you to prove something. So they are giving us this particular equation. And when we have that particular equation, we put it in the first step. That's what they gave us. And so the justification or the reason that goes over here, oops, is given. So now our job is to look this particular equation to this one and figure out what's happened. Well, what I notice is that on the left-hand side, we have 5x, and there's no minus 12 anymore, and that 32 got bigger. So if I'm looking at that, I say, okay, what did they do between steps 1 and 2? They added 12 to both sides of the equation. So from the other day, we know that that is the addition property of equality. Okay, so now we're on to our next step. If we look at between steps 2 and 3, what happened in here? Well, as I look at the left-hand side of the equation, I notice that 5x got smaller to 4x, and 44 is over on the right-hand side without an x, so they must have subtracted x. So now I said they subtracted x, so that means it is the subtraction property of equality. Finally, we have to figure out what happened between steps 3 and 4. Steps 3 and 4, let's see what happened. Of course, they divided. They divided by 4. So we have the division property of equality. When we look at number 2, we're looking to the directions where it says prove that if 12 equals 3 times the quantity of x plus 5 minus 6, then x equals 1. Well, I notice that they say prove that if this, then x equals 1. Okay, so I know that I need to put the if statement right here. So I'm going to say if 12 equals 3 times the quantity of x plus 5 minus 6 goes in the proof in the given spot. You notice that they put given over here. I also know that when they ask me to prove something, it's that x equals 1, I know that that needs to go in the last step. So I'm going to write that in the last step. Well, I feel better already. There's not so many blanks anymore. All right. So again, just like in the last one, we have to figure out what changed between the first and the second step. Well, I look at this and I know what happened here. They distributed. So they ended up with 3x plus 15. That's the only thing that's changed in here. So that is the distributive property. Next, I look at see what happened between steps 2 and 3. Well, if I look at this, nothing happened to the left-hand side again. Nothing happened between here. But I noticed that the 15 minus 16 turned into 9. Okay, so what did they do? They combined like terms. So that is the simplify. another step here. Okay. But there's nothing written here. What the heck? I have to look over here to see that the subtraction property of equality. So, okay, that means that I have to subtract something. I'm looking over here on the left-hand side in step 4, and I say, okay, I have to subtract something. I want to get x alone, so I have to subtract 9 from both sides. So that ends up being 3, and we have 3x. All right, so now I have another step. What did happen here? To get 1 equals x, I divided by 3. So that would be the division property of equality. And then finally, let's see if I can find another color. The last step, we changed it from 1 equals x, to x equals 1. And that, my friends, is a symmetric property of equality. So that's your second proof. Number 3 has us solving for x, and then we're going to have to show our reasons for each step. So this is really just a typical algebra problem. And we highlight this first one, should be yellow, but that'll do. We know that this is our given. So now we have to figure out what we're going to write here. Well, if I look at this problem, I know that I have to do this. I have to distribute. So I'm going to write down the left-hand side as is. And then the right-hand side, this becomes 4x minus 8. So what did I do? I told you I was going to distribute, so that would be the distributive property of equality. No, just the distributive property. Next step, to get to this one. We are going to look at the right-hand side of our equation, and we know that we have to combine like terms. So it's still the same on this side. Combine like terms, 6x minus 8. Well, combining like terms, gosh, that would be a simplify. If you look at your notes, you'll find that. All right, so we're going to move on to the next step. Well, I know I have to isolate x, and I have to get all the numbers on the same side, so it looks like I have to, let's keep it positive. We're going to add 10 and add 10. So if we add 10, we end up with 8x equals 6x plus 2. And that is the addition property of equality. Now the next step. I need to get the x on the one side, so I'm going to take 6x away from this side and from this side. So I end up with 2x equals 2. And since it was subtraction, we call it the subtraction property of equality. Finally, we get to our last step. And how do I get to solve it for x? I have to divide both sides by 2. So So I end up with x equals 1. And since it was division, we say it's the division property. Oops. Of equality. So here's our next one, and you look at this one, you go, what? There's no words, there's no given, I don't get this. Well, actually, our given is right here. This is given. But that still doesn't help me, Mrs. McFadden. Well, actually it does, and I'm going to show you in the picture how this is going to help you. We're looking at the given, which says that AC is 21. If I look at the picture and I say, oh, AC, this whole thing is 21. And then we say, okay, AB is 15. AB is right here. That's 15. Minus x. BC, right here, is 4 plus 2x. Okay. Well, then I've got this stuff right here. That looks like the segment addition postulate. Segment addition postulate. Okay, so then what do I do? Well, I'm going to think of how I can solve this. I'm going to take AB from up here and put it in for AB here. So I'm going to substitute AB for the other AB. So I'm going to write that down. That would be 15 minus x. Then I'm going to take BC and plug it in for BC here. So that's going to be 4 plus 2x. And then I have AC needs to go in here. So that's 21. So what did I do in that step? I substituted. So all that's all just substituted. Now I'm going to follow the next step, which says simplify. So I'm going to simplify it. That means combine like terms. So I got 15 and 4. That's plus. 15 and 4 is 19. Combine these two x's, which comes out to plus 1x equals 21. So I've simplified. Finally, we can get x alone. How are we going to do that? We're going to take 19 away. Take 19 away. X then is 2. And what did I do? That was subtraction property of equality. Okay, number 5. We have a given. Given D is the midpoint of CE. D is the midpoint of CE. going to look at the picture here and we're going to say, okay, D is the midpoint of CE. So by the definition of a midpoint, that means that this and this are the same. Okay, so if I look down at our proof, I see D is the midpoint of CE. Well, we know that that's given because that was up in the directions. So we say given. Our next step down here is to say CD is congruent to DE. Well, oh, that's just what we drew right up here. So when I said that, I said it was the definition of a midpoint. Well, that's exactly what the reason is. Definition of a midpoint. All right. So then I'm looking here, it says E is the midpoint of DF. Oh, we highlight that in the given. E is the midpoint of DF. Oh, yay, it's another given. So if we look at that in the picture, let's take a look at that. E is the midpoint of DF. E is the midpoint of DF. So that means those two are congruent. All right. So we get down to this stuff here. DE is congruent to DF. Well, that's what we just drew in the picture. And that again is the definition of a midpoint. So now they're asking us to prove that CD is congruent to EF. CD is congruent to EF. Well, if this is congruent to this, and this is congruent to this, we can conclude that CD is congruent to EF. And why is that? That is what we call the transitive property of congruence. Okay, last one. We are given LM bisects angle KLN. The ray LM bisects KLN. Well, if we look at that, we see LN in the picture is this ray right here. And that means that it cuts this big angle in two congruent parts. Okay? So if we look at what is going on in the proof, we see LM bisects KLN, and that first reason, of course, is the given, what they give you in the beginning. Now we move over to what's changed between these two. Well, they've given us a hint even. It says that the measure of MLN and the measure of KLN are equal. Well, that is true because it's the definition of an angle bisector. So now what's happened between steps 2 and 3? Well, they took 4x from there and put it in place of this. they took 2x plus 40 and put it in place of this. So that looks like it's going to be the substitution property. Okay. So now, one more step here. From 3 to 4. What happened here? Oh, they took 2x away from both sides. So I end up with 2x equals 40. So that is taking away subtraction. Subtraction property of equality. And the very last step, what happened between the two? We divided by 2. So that is the division property of equality. So everybody come with questions tomorrow, and we will be able to answer any questions and help you out on your homework. So have a great night, and we'll see you tomorrow.